And now I'd like to hand it over to Julia Danon, who's talking about technology in the medical field.
Okay, hi guys, I'm Julia, like Melissa just said, and basically I'm going to be talking about how technology is kind of innovating the medical field and kind of looking towards a brighter future. So the first thing I'm going to talk about is 3D printing, which most of you probably know what that is, but not kind of the way that people look at it in the medical world. So a lot of people know 3D printing as kind of like 3D printing inorganic materials like plastics and metals, which is a lot of what 3D printing is used for today. However, 3D printing is also used largely in the medical field, and it can be used for a lot of different things. So here's a list of some of the things that 3D printing can be used for. And so this right here is a picture of an ear, which is 3D printed from tissue, and it's also like electronical parts. So that's actually a fully functioning ear. So that could be used as a prosthetic for somebody who needs it, basically. This is for like a bone prosthetic, so somebody who needs a knee replacement, that could be 3D printed for them. Also, you can 3D print eyeballs. Fun fact. This is somebody actually who had bone cancer in their spine. This is a 3D printed vertebrae for them, and the reason it has the little holes in it is because as the bone grows, after this is basically surgically implanted, as the bone grows, it kind of fuses with the 3D printed prosthetic. Similarly here, this is a hip, same idea with the holes. This is actually somebody who had a condition where their skull was basically expanding, and it was growing so fast that it was pressing on their brain, and it would have basically caused them to bleed out if they had not received this transplant of their skull, which was 3D printed. So a lot of people ask, like, can we 3D print a heart yet? And the answer is kind of yes and no. We can't actually 3D print organs yet that are fully functional that you can use for transplant. But what a lot of 3D printing is used for is for medical models. So what you're looking at right now is this is a heart valve. And what scientists can do is basically this is 3D printed from tissue. Even though this wouldn't be able to be transplanted to somebody, scientists can basically scan like a patient who has a condition that they need to operate on. And through this CT scan, they can make a 3D print, basically a model of their heart or whatever system they need to look at. And through this, they can do drug testing on this tissue to kind of see how it would react to under different circumstances. And this kind of helps doctors and scientists kind of better prepare for surgeries and stuff like that. So this right here, these are all made out of plastic, but this is like a 3D printed heart, basically. This is actually someone's heart. It's scaled down a lot, but basically what scientists do is there is this one case in Michigan where this girl basically had this condition called tracheobronchomalacia, and basically that means that the tissue in her windpipe is like very weak and it couldn't really support. Basically the tissue couldn't support itself. So it was constantly collapsing in and putting pressure on the arteries and veins around her heart and her lungs, so she was going into pulmonary and cardiac arrest a lot. So what they did was they took a CT scan of kind of like her whole upper chest region, like the lungs and her windpipe and her heart. And what they were able to do with that is they had this 3D printed model now of what the problem was. And with that, they could really kind of figure out how to go in less invasive. So this whole medical model thing is like, it allows for less invasive techniques in surgery, which in turn gives a better success rate in surgeries and basically less recovery time for the patient. And basically what they did is they resolved the problem by 3D printing this kind of like a brace that they would put around the windpipe, and it basically allowed for the windpipe to be supported, and then eventually it just dissolved away. So basically this is how it works. 3D printers that we see nowadays, like that are used to print plastic, are kind of different, actually a lot different than how they're used in the medical world, because obviously when you're printing organic material, it's a whole different thing. So basically using stem cells, muscle cells, vascular cells, that's kind of like what you use as the ink, so to speak, for the 3D printer. And basically the whole problem with the tissue is that when you're 3D printing cells and tissue is that they can't really stand on their own. So they kind of collapse underneath themselves. So what scientists basically do is they make this gel scaffolding. It's kind of like a bath for the 3D printed material to sit in. So it kind of gives it this structure and it helps it stand on its own. And then once the structure is completely printed, they can melt away the scaffolding, and then the structure remains on its own. So this is kind of what it looks like. This is actually, I think, an ear being 3D printed. This is the scaffolding. Obviously, it varies from structure to structure, but this is kind of the general idea. So 3D printers are already saving lives in ways that we wouldn't really expect them to. Like a lot of people, when you think of 3D printing in the medical field, they automatically want to think organs and stuff like that. But like I showed before, there's a lot of other uses for it. So what's kind of looking for the future for 3D printing? There's 123,000 people in this country currently on the transplant list, and every 12 minutes a new name is added. 7% of people die every year waiting for an organ on the transplant list. So realistically, if in the future technology advanced enough so that we could 3D print organs for transplant, it would really allow for people to have a longer life and basically increase the lifespan. So kind of moving into the next area is prosthetics. I kind of talked about prosthetics with the whole 3D printing thing, but a prosthetic is a device, either external or implanted, that substitutes for or supplements a missing or defective part of the body. And you know, a lot of people, when they think of prosthetics, you're going to think of like an arm or a leg or something like that. But there's actually a lot of different kinds of prosthetics. The first kind of prosthetic, which is the one that people usually don't think of when you think of a prosthetic, is a cosmetic prosthetic. So that could be anywhere from like a skin graft, kind of like what I showed before, like a printed ear or stuff like that, like in the eye. That's all a cosmetic prosthetic. But then you're moving into more of like the limb prosthetic. So a body-powered prosthetic would be, this is kind of, the list kind of goes from like less advanced to more advanced. So a body-powered prosthetic is when, say, there was a patient who didn't have an arm. They could have a prosthetic arm and it would kind of be hooked up to the other side of their body, so they'd have it hooked up to this shoulder. So then using this arm, they could kind of control this one. So it's one of the less advanced prosthetics, but it still does the job depending on your circumstances and situation. Then you have externally powered prosthetics, and this is a little bit more advanced. Basically, an externally powered prosthetic has these toggles and switches on the actual prosthetic itself. So say, again, there was a patient that had a prosthetic arm. What they could do is by switching one toggle on it, they would allow, you could twist your wrist, you could have the 360 motion of the wrist, and then by switching another toggle on the prosthetic, you could be able to bend and flex the wrist. Then more advanced prosthetics are myo-electro prosthetics. And basically, when you contract a muscle, so if everybody makes a fist right now, your muscles are kind of giving off these little electrical signals. And when you do that, on the prosthetic, on this more advanced prosthetic, there's basically these sensors that can detect these electrical signals and kind of translate it into motion for the prosthetic. So a myo-electric prosthetic is definitely one of the more advanced prosthetics. Then I'm going to talk about the robotic prosthetics in a little bit, but those are the most advanced ones. So this is kind of where we began with prosthetics a while ago. The one on the left actually dates back to ancient Egypt, so that was one of like the first prosthetics ever discovered. And then the one on the right is made completely out of iron, and that dates back to around 1560. So obviously we've come a pretty long way. Today, this is an example of the myo-electric prosthetic. So you can see on this man that on his shoulders, he has these sensors that are basically built in, and those are the sensors that are detecting the electrical signals when he contracts those muscles. Okay, so now moving into the robotic and the bionic prosthetics. These are the most advanced types of prosthetics. Basically how it works is that probes are surgically implanted into your brain, the patient's brain, and into the motor cortex, which is the area of the brain that controls your function and your movement. So the electrodes in your brain basically detect signals from nearby neurons, and these signals are basically decoded by a software that's pretty complex and allow the patient to move the limb. So for somebody who's completely paralyzed, if they have this procedure done, they can basically just think about moving their arm and the prosthetic would move. Okay, warning for anybody who's kind of squeamish and doesn't like to look at gross things. The next picture I'm going to show is the inside of someone's brain, so if you don't want to look, just look away. Basically, this is the sensors that are implanted into the motor cortex. And once they're implanted, they basically, well, they close the skull and stuff. And there's these two little like ports that doctors and scientists can basically like mess around with, and they can like interact with the sensors on the inside of the brain. So basically, there's this one case, and this woman was completely paralyzed, and through this, through these technology, she was able to move an arm basically, and if you can kind of tell that this is kind of where the future of this is going. I mean, there are people who have been, just in this case, this woman was paralyzed for 14 years. There are people who have no motor function in any of their limbs in their body. So this is really kind of looking towards a brighter future for these people, even though it's, all of this stuff is really still in the clinical trial phase. So, you know, it's really only been going on since like 2005, which isn't that long ago in the grand scheme of things. But yeah. So, kind of a combination of the two is the problem with prosthetics, especially these really advanced ones, is that one of the robotic prosthetics can cost up to $400,000 just to produce. So obviously the main problem here is with the cost. So this is one organization that I found. This isn't for very advanced prosthetics, but it's for kind of the less advanced ones. Basically, anybody who has a 3D printer at their disposal, so like here in school we have like 3 3D printers, they can basically, there's a team of medical researchers on the other side. It's this big organization, and basically they have the 3D blueprints for a specific child who doesn't have a limb, usually it's arms, and they can send it to anybody who has a 3D printer, and basically the person who's 3D printing it just downloads the blueprints, 3D prints it, puts it together, and then gives it to this child. So this is kind of one of the ways that these technologies are kind of coming together to make the whole thing more economically friendly. And yeah, basically, that's it. Any questions? Yeah.
The ones you say we have them at school here.
Yeah.
Have they ever done the Enabling Our Future program?
I don't think so. I mean, I was looking into doing it, but you kind of have to, it's kind of like an individual thing, so you like sign up, and it kind of takes a while because there are a lot more people who want to donate and help out than there are people with amputated limbs. But yeah, basically really anybody can do it, and you don't even have to get paired with a child. They have, on their website, they have basically blueprints for like basic prosthetics that you can make and then send out to them that they can use. Yeah.
Do you know what like the cost difference is between like a 3D printed limb compared to however they used to make?
You mean like a...
Or like just 3D printer like seriously cut the cost for?
Well, it kind of depends on the material. I mean, you can see that like it depends on the part. Like if you're 3D printing, it's kind of a less of cost, but better, like even better way to like mass produce things. So kind of like what I like to relate it to, if I had to choose an analogy, I'd choose like basically cars. So you know when cars first came out, not a lot of people had them. They really weren't. They were kind of like a luxury thing. But as time progressed, they became more economically friendly, and they found more ways to mass produce them. And obviously now basically everybody has cars.